Ready?
Mm-hmm.
Okay. So now we're going to talk about one of the endocrine glands in particular, okay? And that's the thyroid gland, which is found right at the kind of base of the neck. And as it says, it's butterfly shaped, so it fits over top of your trachea. But the thyroid gland in particular produces three main hormones. A lot of the glands that we will talk about will produce more than just the hormones that we mentioned, but for Bio30's sake, these are three that you're going to encounter coming from the thyroid gland. The first two have the same function. So thyroxine and triiodothyronine both will increase your metabolism. What does it mean to increase your metabolism? Basically, that means your cells are going to be revving the gas. So they're going to burn sugar faster, they're going to produce waste faster. As a person, you're going to feel alert, awake, warm because you're burning fuel. If you are low on that, you're going to kind of feel the opposite, cold, slow, you'll put on weight. Right? So that's your metabolism, and these hormones control it. So they're going to get to every body cell and they're going to say, like, rev up a little bit. Okay? If we're low on that, it's going to slow those cells down. And that's going to fluctuate. I mean, all hormones have a happy level. So if we look at kind of a graph of time and hormone level in the bloodstream, and over time, that hormone level is going to have kind of a happy zone, right? And if your hormone's in that happy zone, your body's functioning well. If it comes up like you have too much of it, then your body's going to try to make some changes to bring it back into that happy zone. And if it dips down, it's going to produce some more of those hormones to bring it back into its happy zone. But on a day-to-day, week-to-week, month-to-month, year-to-year life, that's going to fluctuate constantly, no matter what type of a hormone. Trying to keep it in that optimal zone is what we call homeostasis. We want to try to keep everything in our bodies running at that optimal zone, even though sometimes it's high and sometimes it's low, and often that is as a result of interactions that we have with our external environment, right? Okay, so like if we go outside and it's minus 25 degrees Celsius here like it is today, we're going to start to burn sugar, or need to start to burn sugar a little bit faster. So we probably will release a little bit of thyroxine, and or triiodothyronine. And that's going to speed up our cells, so we burn a little bit more sugar faster, so that then we produce more heat, right? And we also might have a physical reaction to that, in that we're shaking and shivering a little bit, okay? And so that's going to speed up our metabolism, produce more heat, keep us warm on these cold winter days, okay? That's homeostasis. So that's the body's reaction to try to keep things running at the optimal level. Okay, the other hormone that it releases is called calcitonin. And when we talk about the parathyroid gland, we'll mention calcitonin a little bit more, but its job is to decrease the calcium level in the blood. So it's the same thing. If we're looking at calcium level, if we go and eat something, like drink a glass of milk, our calcium level comes up. Okay, so it's too high. We want to keep it in our optimal range of calcium. So we release a little bit of calcitonin, and it's going to lower that calcium level. Eventually, we might have it too low, okay? So then we have another hormone that will actually bring it back up. And so calcitonin, the one way to remember this, I always give little tricks on how to remember things. So calcitonin sounds like calcibonin, and that's exactly what it's doing. It's taking the calcium from the blood, right? And it's putting it into your bones. So it's making your bones a little bit more calcium dense, calcium rich, so that it keeps that blood level lower. Okay, we need calcium in the blood because it's an important element that helps us contract muscles and do all kinds of other things. So we want it we want some of it in there. We don't want too much and we don't want too little.
Right.
When there's too much, calcibone in. Put the calcium into the bone. Okay, easy way to remember it.
Mm-hmm.
The other thing is the thyroid gland is controlled by the pituitary. We mentioned the pituitary is sometimes called the master gland because it releases hormones that will work on to signal other glands to release their hormones. Okay? And the thyroid gland is one of those in particular. So we have a hypothalamus, which is a part of our brain, and I refer to it as like the lab of our brain. So it's always monitoring, say, your blood levels, your oxygen, carbon dioxide. It's going to monitor things like calcium level. It's going to monitor things like the level of thyroxine in your blood. And so it's testing that, and it's going to, if the level is low, level of thyroxine is low, it's going to signal to the pituitary, which it's got a direct connection to, and it's going to release something called thyroid releasing factors. And anytime the hypothalamus talks to the pituitary, we can just say it's going to release some releasing factors. And it's going to say, hey, pituitary, do you have anything that you can send down to the thyroid gland down here to wake it up? And the pituitary should say, well, yeah, I do, right? And it's going to release something called TSH, which is thyroid stimulating hormone. Very aptly named because it's going to stimulate the thyroid gland. Now, normally the thyroid gland will then produce thyroxine, which will affect the body cells by making them speed up their metabolism. And it's also going to feed back negatively because remember, it's traveling, all these things are traveling through the blood. And once you're in the blood, you go everywhere. So it's going to make its way back up to the hypothalamus. And the hypothalamus is going to say, oh, I see the thyroxine. Right? Perfect. I don't need to tell him to make any, and he doesn't need to tell him to make any more. So we call that a negative feedback loop. When you have enough of this, it's going to turn that off. If you don't have enough of this, then this is on.
Right, yeah.
Okay, kind of like your thermostat on your wall turns on your furnace. Right? When it's cold, you don't have enough heat. As soon as the furnace warms the place up, the heat is getting back to the thermostat and it's turning it off again, right? Same kind of a switch. Now, the thyroxine is also going to act negatively on the pituitary gland. So we call this a negative feedback loop involving the hypothalamus pituitary complex and the thyroid gland. In Bio 30, you might see a question like draw and label a negative feedback loop that involves the hypothalamus pituitary complex and insert gland here. It could be the thyroid gland, it could be the adrenal gland, it could be a different gland, but there's a number of different negative feedback loops. Okay, this is for the thyroid gland in particular. This is important because iodine is an essential component of thyroxine and triiodothyronine. And we get iodine from the foods that we eat, especially things like seafood. Right? It has lots of iodine in it because it's getting it probably from living in the ocean and absorbing it itself, right? And so as long as we eat iodine, then the thyroid can make thyroxine, and the thyroxine can control the metabolism, and the thyroxine can control the negative feedback loop. But
meaning that the hypothalamus and the pituitary doesn't have to turn on.
Doesn't have to turn on.
Okay.
Exactly. So if we're low on iodine, which nowadays doesn't happen as much as it did kind of in the days of when they were settling Canada and traveling across from Europe, and I'll tell you why in a second. But if we're low on iodine, okay, then the thyroid can't make this.
Mm-hmm.
So therefore, this is not working. It's not shutting these off. So these guys, the hypothalamus is stimulating the pituitary, and the pituitary is stimulating the thyroid, and it keeps stimulating and it keeps stimulating. It's like, hey thyroid, hey thyroid, hey
Yeah.
thyroid. And pretty soon the thyroid goes, "Grrr," and it swells up. And that's what a goiter is, right? A goiter is a big swollen neck because of the swollen thyroid gland, which is swelling because it is being overstimulated by the pituitary gland, which is being told to do that by the hypothalamus because you don't have enough thyroxine, right? So they often call goiter inland disease. So if we look at, there's Hudson's Bay. Oh, we need James Bay. Here's Canada, right? And we have BC, Alberta, etc., etc. So settlers came in here by ship.
Mm-hmm.
As they started to settle the prairie provinces, they got further and further away from the ocean.
Mm-hmm.
And their diets changed to things like maybe some grains and that kind of stuff, wild game. But they weren't getting as much iodine. And so this was more prevalent. So what they had to do was try to get a source of iodine. And there are certain vegetables in there. I mean, if they got seafood, they could use that. And as soon as you add iodine, you can make thyroxine and the goiter goes
Right,
away.
yeah.
So what they have now kind of mandated in probably many countries is the use of iodized table salt.
Oh, okay.
So if you look at your table salt that
Yeah.
you pour into your salt shaker, it'll say iodinized or iodized table salt, which just means they add iodine to it.
Oh, okay.
So everybody's getting some of that. It's pretty hard not to get salt in your diet. If you look at every package of every type of food, there's generally some salt in it, and likely it has iodine added to it.
Okay.
And so the frequency of goiters worldwide, probably nowadays, has decreased because of that. Okay? And that all has to do with the thyroid gland and your metabolism and negative feedback loops.
Yeah.